All right, hello, whoever's watching this. This is the very, very first lesson of this book. Very first lesson, very first chapter. They call them modules. I call them chapters, whatever. It's fine. Module 1. We're going to skip through this first page. We're not going to do the before after type thing yet. But I told them to do the quick check right here, just as kind of a warm up, get started. We're going to do quick check number 4, and we're going to do quick check number 8. So, Z. What quadrant did Z live in? Do you remember your quadrants? 1, 2, 3, 4. It's in the fourth quadrant. 4, 2 is right here. Get into the habit of when we start to plot points, especially if you're doing more than one on a coordinate plane. I only asked you to plot one. But if we're doing multiple ones, put the letter next to the dot, so we can distinguish between which one is which. Does that make sense? So start doing that from now on. Put the letter next to it. Okay, number 8. This is kind of an order of operations thing. Why do they use brackets instead of parentheses? Not necessarily. Brackets are treated exactly the same as parentheses.
Outside of parentheses.
Yeah, they just do that so that you don't get confused on which is which. You could have used parentheses here and here, right? We would have just had a set of parentheses around the 6 inside of the parentheses. So it just makes it a little bit easier to distinguish which opens and which parentheses open and close together, right? So that's the only reason why they do that. All right, so this one right here, if you're gonna do all of the stuff inside this parenthesis, this is -3 plus 4, so that is 1, and 1 squared is 1, plus -1 plus 6 is 5, and 5 squared is 25, so the answer is 26. Did you guys all get 26? Perfect. All right, there you go. Moving on, let's start the lesson. This is 1-1, so we are now on page, I don't know what this is, page 3. I'm going to skip through a lot of this stuff, but we'll go through and hit the highlights, I guess. The axiomatic system has to do with geometry. We have some things here to talk about. We have some, yesterday we talked about proofs and how you will eventually get to the point where you're doing proofs in this class. And in order to prove something, you have to have some facts, right? Like when I say, prove to me why you should be able to go out on the weekend, if your mom says that, you have to have some facts to support it, right? Well, I cleaned my room, I did the dishes, I mowed the lawn. You have to have some facts to support it. There are different kinds of facts that you can use to support. Some of them are just definitions, okay, which is there. An explanation that assigns properties to a mathematical object. That's just a definition. I was trying to figure out what the difference between a definition and a defined term was. Here's what I came across. So if we're talking about like a plane, like points, lines, and planes, not like an airplane, but like a flat surface plane, and you have a plane, and the definition of a plane is blah, blah, blah. The defined term is plane, the definition is the other part. Does that make sense? So they're just like the two pieces of the definition. Okay, so defined term is the word, definition is what it means. Okay, here's the two important things. Axioms and postulates and theorems. I don't call them axioms, I call them postulates, but I think the book refers to them as an axiom. Your homework assignment, they say axiom instead of postulate. I'm used to saying postulate. So they both are interchangeable, they both mean the same thing. And really, postulates and theorems are kind of the same thing. They're both like kind of definitions or things that have been stated as true. They're like facts, okay? Both of these are facts. Let's write that word down. These are facts. A postulate is a fact and a theorem is a fact, right? But postulates are facts that are just accepted as true without having to be proven, right? It's like the sky is blue, or like the sun came up today. I don't have to prove to you that the sun came up today. We just know that, right? Okay? Versus a theorem is something that has been developed using something else. Like the Pythagorean theorem has been developed using other facts about like triangles, right? Okay? Other facts about triangles go in to support the Pythagorean theorem. But all of those are accepted as facts, okay? So the way that I think about it is postulates and theorems, they're both facts, but where did I just go? But theorems are like the big brother to the postulates, which are like the baby sis, right? Postulates are the babies, theorems are the big guns because they have been proven, right? Okay, so these are just facts that we're using to support things that we're proving over time. Okay, there you go. So we take an undefined term, we develop a definition, we develop an axiom, which is something that doesn't have to be proven, and then we develop a theorem, which is using that. We use these axioms and these postulates to prove theorems to come up with other accepted facts, right? Other things that are accepted as facts. Okay, good. All right, let's go to this one. This section is all about like kind of reasoning and just like developing and sorting out information, I should say, sorting information. So they give us a big long paragraph here. And whenever you get a big long paragraph, try to paraphrase it and write stuff off to the side. So here, we're gonna do that here in a second. Animals in the fictional country of Rythoth, maybe? Yes, okay. Blue animals are from the mountains. Oh, that sounds like a list. Let's do it. Blue equals mountain. I'm gonna paraphrase here, MTN. Blue means mountain. Red animals are from the valley. They're from valleys. So blue equals mountain, red equals valley. That's about their color. Now they're going to give us some other information. Am I going too fast? Okay. They say mammals, birds, and reptiles. Okay. Let's use a different color. Mammals. I spelled it this morning with one M also. Mammals, birds, reptiles. All right. And it is considered to be a mammal if what? Fur or hair. Hair or fur. Whatever. Okay. Birds. It's a bird if it has feathers. And it is a reptile if it has scales. Now we can figure this out a lot easier and we don't have to go back to the paragraph to sort out our thoughts. Okay? So, wow, I really have to zoom out to do this. And it won't let me zoom out that far. Dang it. Oh, yes, it will. There we go. We are going to fill in this box down here. You see that box? Okay. So, oh, man. Okay. Notability, this app that I use to do all these notes just went through an update, and I can't find where anything is at now. Ugh, I hate it. So, bear with me through the glitches. All right, let's fill in this table. So, the very first box is a mammal and a mountain. Which one is a mammal that has hair and from the mountains that is blue? The Rorks, however you pronounce that, okay? So put him in there, R-O-R-X, okay? Let's go to the right. Which one's a bird from the mountains? Birds are feathers and mountains are blue. Feathery blue. The Pax, okay? Reptile has scales and from the mountains is blue, so scaly and blue. Anybody want to take a stab at that? AWUB? I don't know. If you have a better guess, AWUB. Okay, all right, valleys. Valleys are all going to be the red ones. Okay, so mammals have hair. Which one's that? The club. Okay, birds have feathers. That is the prit. And the scaly one is the zog. Make sense? So we're just taking information from the paragraph and we are deciphering it and putting it into a conclusion. Okay, now this is an axiom. So it says use the previously given axioms in the table you filled to draw 3 conclusions. Some of your homework is going to say, draw me some conclusions. Well, you can draw lots of conclusions. The blank is a mammal from the mountains of Rythoth. Which one is a mammal from the mountains? We're using this table to find out which one's the mammal from the mountains. The Rorks, right? That's a conclusion that we can draw. The blank is a reptile from the valley. Reptile, valley. You see it? Which one? Zog. I know these words are weird. Like, how do I pronounce that? The blank is a bird from the valley. Bird and valley. The prit. These are all conclusions that we're drawing. Okay? Good? Sound good? These are axioms. They're just, we don't have to prove that that's a thing. An axiom is not proven. It's just kind of like a sorting out information and taking the fact. Okay? Which one's the one that's that is proven? Theorems. Theorems are things that are proven. Yep. Okay, should we do the check? The fictional galaxy of Yogol contains at least 20 planets, including Mothra, Sothra, and Kothra. An animal can live. Oh, how did I just get that in there? Go away. Undo. Nope, nope, nope. No. Go. Oh, there we go. Got it. Okay. I don't know. An animal can live on any planet in the Yogola galaxy that contains its biome. You see the biomes over here? The desert is red. The tropical forest is green. And the tundra is blue. Okay. All right. Up here it says lizards and scorpions live in the desert. So over here I'm gonna put lizards, scorpions. Okay, I'm gonna paraphrase so you don't have to write the whole word. Okay, frogs and monkeys live in the tropical forest. So I'm gonna put frog, monkey. You see how I'm organizing this information? Tundra, who lives in the tundra? Bears and foxes. Is foxes a word? I thought it was like,
I'm pretty sure it's just a fox.
I thought,
No, it's
I don't know. Foxes
Like
is a word.
sheep or something.
Like sheep, a sheep is the same as, like, sheep is one or sheep is plural, right? Like, sheep is sheep.
I feel like I
You don't
just say
say
like there's
fox
some
or
fox.
plural.
Like I would say there's some fox.
You say, you don't say mini fox, you say mini foxes.
I don't know.
I
I don't know.
say fox, so-
I don't say anything about foxes because I don't see it. I don't ever see any. I about hit a skunk this morning. That's as far close to a fox as I've gotten. Anyway, all right. Use the axioms. Axioms are like these little facts and determine what conclusions. We're drawing conclusions. Okay. Select all that apply that are true. So I'm looking up to this diagram here and then like this box that I've designed over here to the side to come up with this stuff. Okay. Some of these are true. Some of these are false. Let's just figure out whether they're true or false. Bears and foxes can live in Sothera. Okay, bears and foxes live in the tundra. Is there tundra on Sothera? Yes, true. Okay, lizards and scorpions, they live in the desert. They can only live on Mothra. Why? There is some desert. You see the red on Kothera? Okay, so they can live. So that can live on Kothera. So false. Only frogs and monkeys can survive on Kothera. Frogs and monkeys are in the rainforests, right? Frogs and monkeys are in the rainforest, and Kothera.
True.
Is that true?
True.
Frogs and monkeys can survive on. Yeah, that's true. No.
It's false because more than
Says
those two can live on.
Oh. Only frogs and monkeys. Yes. So the fact that it has red means that also lizards and scorpions can live there as well. That's why it's false. I knew it was false, but I'm like, I think it's true. Okay, we weren't reading the only part. Only. All right, here's the deal. D. Bears and foxes can survive on Sothera at temperatures as low as -20. Now, we know that bears and foxes can survive on Sothera, right? But we know nothing about the temperature. So that's false because we don't know anything about temperature. The first part's right, yes, but they don't tell us anything about temperature, so we don't know that for sure. So that is not a conclusion that we can draw at this time because we don't know anything about temperature. Okay, all animals can live on Kothera. False because there's no tundra, so false. Scorpions and lizards can live on Mothra. True. Okay, so select all that apply. A and F are the true ones, which is weird because false starts with an F. Anyway, A and F are the conclusions that can be made. Got it? Good? All right, last little bit is the two different types of geometry. Circle synthetic and circle analytic, so you can find those words easy. Synthetic are geometric figures without coordinates. Underline those words. Geometric figures without coordinates. So it's like if I put this cube in front of you, that is the study of synthetic geometry if we're talking about cubes, right? Or a cylinder, or a diagram, or a picture of a triangle, or anything like that. That's all synthetic geometry. Okay, analytic geometry has coordinate systems, like a coordinate plane, like plotting points, right? So the first question on your quick check where you had to plot that point 4, 2, that is analytic geometry, okay? You're analyzing points, analyzing points, okay? Synthetic is the shapes and other stuff. Okay, here we go. Let's go fast. Out of these 4, synthetic does not use coordinate planes. So which ones are synthetic? The first one and the last one, the 2 corners. Okay, the other 2 are analytic. We are analyzing the coordinate planes. I'm just going to put SASA or SAAS to be lazy. You can do that as well on your homework assignment if you would like. I don't care. Okay, bottom. Which ones are synthetic? Second and the third. I went to go write an A. Synthetic, analytic. You're analyzing points. Okay, with a coordinate plane, without a coordinate plane. That's it. We're done with lesson 1. Do on the practice just 2 through 22 the evens. Okay, and we're gonna go to number 14 real quick, because it asks you to gather some data. Okay, to gather some data. All right, so number 14, go there real quick. Survey a group of students in your classroom about favorite colors. Write 3 axioms about write 3 axioms. Then use your axioms to write a conclusion. Okay, so we're gonna gather some data. We're gonna do 3 axioms, which means I'm gonna pick 3 colors and you tell me which one's your favorite out of all of you. Okay, there are 9 of us. Okay, what needs to be on the list? Blue?
Yeah.
Blue needs to be on the list. What else?
Red.
Red and pink. So out of those 3, we gotta pick between blue, red, pink. What are you, Mallory?
Pink.
She's a pink. Ethan?
Blue.
Blue. Ailey? Pink. Brian? Oh, I just erased it.
Red.
Okay, red. Araceli? Red. Remington?
Blue.
Blue. Whew. We're gonna have a tie here. Okay, Megan?
Blue.
Yep, blue. Okay, Matthew?
Red.
Red. Oh man, and Delaney?
Pink.
Okay, there you go. All right, then use your axioms. These are my axioms. These are my facts about our class, the 3 facts that I have about my class. Write a conclusion. Do you know how to write a conclusion? What would your conclusion be?
The colors are all
3 people like.
equally
3
liked.
people like.
You could say 3 people like blue, 3 people like whatever, or you could say what Megan said. I like that one too. All of them are equally liked in this class. All 3 colors are equal
Do we have to
preference.
write down the blue, red, pink, and
Yeah, go ahead and write that down. Yeah, just so you can see it and so I can remember. Okay? Anything else? Okay, when it says write an axiom, you're just like writing out the facts or writing out the conclusions, okay? All right, I'm gonna stop this video. Goodbye, Chloe, or whoever's watching this.